Hello, my name is Arya Shahdi. I'm one of the developers of SP-Depo wax deposition software under single phase and turbulent flow with Dr. Panacharoensawad. In this tutorial, I'm going to talk about how to run the program and how to get results and the characteristics about wax deposition phenomenon. Okay, so actually, let me delete all of these sections. Okay, so user should put all these following files, okay, into one directory which is called exe files. In my case, so as you can see, there are some Python files which are used for data visualization, and also there are two exe files over here. One which is created from C++, the other one is created from C#. In SP-Depo, we used C++ and C# for our development. The core scientific computation, which is related to the wax deposition model, is coded in C++ with over 12,500 lines of code and 350 methods and 40 classes. And C# graphical user interface was used to develop a user-friendly interface for our software. So we're going to click on the SPDepo GUI.exe, and this is the symbol of our software, our SP-Depo. So if you click on File, you have two options. You can make a new project and provide all the input information from the very beginning. However, due to the restriction of time, we're going to open an already saved input files. Okay, and this new window is going to pop up. So in this new window, the user can provide input information. So each tab is related to a certain functionality or input information. So the liquid properties. So within the liquid properties, you have to provide, for example, equations for density and viscosity. Density and viscosity change with temperature, so that's why they should not be provided with just one value, and equation format is required. So if you click on the edit equation, so within this within this window, we made it possible so user can choose a wide variety of equations for their desired parameter. Okay, and if you click on these the help button, okay, you can find two manuals which tell you exactly how to put the information or to put the equation. So you provide pipes properties, inlet condition, surrounding input information. Then we're going to code the simulation options. So in SP-Depo, we made it possible so that user can use a different model, wax deposition models as desired. For example, someone trusts a certain model more than the others. Okay, we made it possible. So for example, crystal aspect ratio parameter can be chosen either from Sing or Lee models. Also for Lee model, user can choose the precipitation rate. And also in this section, Panacharoensawad 2012 model can be used with their corresponding fitting parameters. However, one thing I want to talk specifically is the precipitation curve model. So basically, in a traditional way and common wax deposition models, the precipitation curve, which basically tells how much is precipitated at each temperature, which is one of the main required inputs in the wax deposition modeling, is usually provided through a fitted equation. So experimentally, either experimentally or by modeling, the precipitation curve is made, and the fitted equation is going to be derived and provided for the wax deposition modeling. The same for dc/dt. And also wax molar volume is given just by only one number. This is a traditional way, has been used in Sing 2000, Lee 2008, Panacharoensawad 2012, Ritrang in 2014. However, as a part of my PhD, I developed another wax deposition model, which is called SP-Compo. An SP-Compo model is a thermodynamically coupled wax deposition model, which engages SP-Wax thermodynamic tool, okay, and incorporated in wax deposition calculation. So SP-Wax thermodynamic model is my first software which was published in SoftwareX, and you can go and download it and use it. So now that the thermodynamic model is initialized and appropriately assigned, let's go to the model tuning. So in the simulation options tab, we show that, okay, for example, if you use Panacharoensawad 2012 model, it has two fitting parameters that need to be adjusted based on the experimental data. So in the model tuning tab, okay, we're gonna provide the input, the experimental data about thickness, wax fraction, and average carbon number distribution. Average carbon number distribution of the solid phase of the deposit. Okay, now that we provide that, okay, then we can click on. So let's create all the input, because whatever changes you make over here. So in order to translate these changes to the input file, which is going to be read by the C++ exe file, need to be created by clicking this button, create all input file, and then you choose parameter search. So when you choose parameter search, okay, as remember, so we coded Levenberg-Marquardt optimization tool, okay, into our program to find the adjustment parameters, okay, based on the given experimental data. So after finding optimum values for fitting parameters, which in this case is MSR1 and MSR2 from Panacharoensawad 2012, the values, the optimum values of the adjustment parameters are chosen. This takes about 1 minute. So in order to skip this, I'm gonna close this because I had already run it, and I know that these two values are the optimum values. Around the optimum value is not exactly the same, but it gives good prediction. So then we're gonna perform the calculation. So if you click on this, Levenberg-Marquardt is not gonna be run, it's not gonna be called. Instead, the main wax deposition model is going to be called and will be running. So let's give it up about like 20 seconds. Okay, and so the data are created. So as you can see in the directory, all the input files are created. All the results are created, and if you go to the results visualization and click plot, and you can see the thickness data are plotted against the experimental data. So is a wax fraction data. Also, temperature data can be accessed over here, and the temperature profile it can be plotted for different time. But most importantly, which is one of the main contribution of our software, is to predict solid phase composition of the deposit. Okay, as you can see, the deposit solid phase composition can be predicted for different temperature, either interface temperature or deposition temperature or wall temperature. And here, okay, average carbon number distribution, average carbon number of solid phase, of deposit solid phase composition also is plotted for these three temperatures, and we provide a lower and upper bound for it against the experimental data. And for last, and also over here, you have all other information which are crucial for petroleum industry. So in the last step, if you go to the developer's manual, okay, you see a map that tells you about the header files and all the functionalities. And if you click on one of them, it's going to take you to the page that it is related to that header file. Okay, for example, here is about linear regression, and it explains what it is. So this was I hope my explanation was enough. Email address is listed. You can email me if you had any question. Thank you so much and have a good day.